Alright, our question 4 ufocus lana kuma Newton's laws, the universal gravitational law. In the description box kunama links for other recordings engwayenzile for this question paper. So for now siphendulana on question 4.1, but state Newton's law of universal gravitation in words. The law states that every body in the universe attracts every other body with a gravitational force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Interesting. So nangabune crash, you know what to do. Uvela umkhombise le formula lena, I'm sure ukuthi uzokugcoma. Anyway, 4.2, la ku 4.2 basiphe a graph, right? Bese bathi kithi the velocity time graph shows that the velocity time graph shown below describes the motion of an object of mass m thrown upwards and then falling downwards on planet X for 5 seconds. From 1 to it's for 5 seconds. So ukuthi bayiphosele phezulu. Maybe there's another planet mhlambe, so where we want to study i gravitational force yakhona. Then we throw an object upward, then it comes back after 5 seconds. Then obtain this graph. Assume that the only force acting on the object is the gravitational force of planet X kuphela. There's no other force acting on the object besides the gravitational force of the planet. So this is the sketch, the velocity time graph. And then bese babuya basiprovide ngenye information bathi the radius of planet X is 6.22 times 10 to exponent 5 meters. This is the radius. Using the graph above and relevant formulae, calculate the mass of planet X. Interesting. But guess what? Sifuna ini? The mass of the planet. Right? Sifuna the mass of the planet. Guess what? Using this velocity time graph, we can actually calculate the gravitational force, the gravitational acceleration for this planet X. The gradient, we can use this point, this point, now which one? Maybe not this one. Yes, these 2 points. Remember, for calculating gradient, you can use this one and this one, or this one and this one. It's up to you. Just you need a pair of 2 points, just like maths. Now calculating gradient on a Cartesian plane for a straight line equation, you think 2 yama points. So now we do the same thing. So the gradient is equal to the change in velocity divided by the change in time, or the change in y divided by the change in x. So this is y, this is x. That's why I need to change in velocity over change in time. So the gradient is the acceleration. So the acceleration we calculate, it's the gravitational acceleration. So nangabeng the gravitational acceleration, there's a formula engayisebenzisa for calculating the mass of the planet. In a moment, let's calculate the acceleration here. To the gradient is equal to this point, and this point is equal to 0 minus 20. So it's 0 velocity minus 20 divided by 2 minus 4, which is the change in time. This is equal to 0 minus 20, it's minus 20. 4 minus 2, 2 minus 4 is equal to minus 2. This is equal to minus 20 over negative 2. Divide, divide la. The answer is equal to 10 meters per second squared. This is the acceleration here. So on the planet X, it's an acceleration of 10 meters per second. So go planet Earth, we know that our gravitational acceleration is 9.8 meters per second squared. So Lena, it's 10. So now I round it off. So this gravitational acceleration is close to our gravitational acceleration. It might happen to planet Earth, but we don't know. We don't know for sure. But anyway, so there's a formula C7 for calculating the gravitational acceleration for any planet. For any planet, for any planet, right? As long as was a radius of that planet as well as the mass of that planet, to say inside this formula. I'm not sure what this formula by comba kuma formula sheet, but it's a formula okwamele uyazi ke this one, especially now about to calculate the gravitational acceleration for a planet, the mass of the planet, the radius of the planet. This is the formula we apply again. Then we substitute 10 is the gravitational acceleration, g is the constant times the mass, which is the mass in we calculator for planet bunny x, and then this is the radius basiphe yona nayo lapha, it's the radius squared. Then I cross multiply salana log, then divide the both sides by the constant 6.67 ngithola this. Now asithole answer yethu ke manje equal to 10 times 6.22 times 10 raised to exponent no, it's not minus 5 but 5 asivale bracket la and square yonke lento lena and square this, squared divided by 6.67 times 10 to exponent minus 11. This is equal to 5.8 times 10 to exponent 22. So this is our answer, 5.8 times 10 to exponent 22 kilogram. But our question A, by the way, our question 4 there's a last question 4.3. I think erase so that we do the last one. Alright, now 4.3. A satellite is orbiting planet X. Yes? A satellite is orbiting planet X. When the satellite is on the line joining the centers of planet X and planet Y, the net gravitational force acting on the satellite due to planet X and planet Y is 0. Right? Now satellite yethu. This is the satellite. Once our satellite is in the line between X and Y, we get a net gravitational force of 0. So now, meaning the gravitational force exerted by planet Y and the gravitational force exerted by planet X on the satellite, they are both equal to 0, right? This one, okay, planet X will attract the satellite to the right, and then planet X will attract the satellite to the left. Remember, universal gravitation 18, everybody in the universe they attract, right? So planet X ufuna attract, planet Y ufuna attract, right? So that's the case again. Yes, that's the case. So F network corner is equal to bani, is equal to 0. The distance between the centers of planet X and planet Y is 1 times 10 to exponent 7. That's like a million. Nah, 10 million. Yeah, something like that. 10 million meters. If the mass of planet Y is twice the mass of planet X, calculate the distance of the satellite from planet X. So sifuna the distance from lagu X all the way up to bani to the satellite. Sifuna this distance, right? Sifuna this distance. Yes? Okay, 4.3. We know that F net is equal to 0 due to the 2 planets on the satellite. It means that F, the force of planet X, the gravitational force of planet X on the satellite is equal to the force of planet Y on the satellite. Therefore, I started, for instance, okay. Let's do this. Let's say the distance between planet X and the satellite is equal to X. Right? And so you let distance and if now calculate the distance of the satellite from planet X. The distance from here to here. Let's take it as X. It's the unknown distance. It's the distance as for we calculator let's call it x. That's the idea, right? So therefore, the force of gravity between planet X and the satellite is equal to g times mx times the mass of the satellite divided by x squared, which is the distance r between the two objects, the two bodies. And then for planet Y, we do the same thing, g times mass y times the mass of the satellite divided by, this time around you minus the distance from lana to lana. Nang minus x, I get the distance from here to here. If I minus x from this distance, ngithola the distance from la to la. So the distance from the satellite to planet Y is 1 times 10 exponent 7 minus bani x. Hence, ni divided by this one squared lapha, right? And then what we have asitshela bathi okay, mass ka planet Y is 2 times, if the mass of planet Y is 2 times the mass of planet X, it's 2 times m la. My is 2 times mx. Yes, let's keep it this way. As we keep it this way, as we remove my sifake ubani mx, izoba useful at a later stage. Uzobona manje. This is equal to, if force ka F, remember sitheni, if force ka X, this one is equal to this force because of F net is equal to 0. So this is equal to that, right? Then G, you cancel out G. M, I cancel ubani, M. And then MS, I cancel ubani, MS, right? I cancel MS. Then ngizosala na this. Sala no 1 over x squared equal to 2 over 1 times 10 exponent 7 minus x squared. Then we cross multiply 1 times this, we total 1 times 10 to exponent 7 minus x squared equal to 2 times x squared. It's 2x squared, right? It's 2x squared. Okay, lento ekuzoyenza manje, your maths teacher angakuthethisa for yona this thing. But because of this solution is a provider 2 yama solutions. Yes, because of this is a quadratic equation, is a provider 2 yama solutions. It means that a1 yoba negative, a1 ibe njani, ibe positive. So that's why ngi square up both sides la. I only need one solution. So bheka, the square root cancel this squared, and then the square root of 2x squared is equal to square root 2x. Therefore ngapha kusala 1 times 10 exponent 7 minus x. Voila. Therefore siyaqhubeka nayo, ngithi 10 times 10 to exponent 7 is equal to square root 2x plus x. Basically it transpose x to the right hand side. Therefore what is square root 2 plus a 1? Remember x was 1x lapha, so we add the like terms. Square root 2 plus 1 is equal to, asibhale, okay, let's say asisegu fixed to 3 decimal places, maybe 2.4.1. so it's 10 times 10 exponent 7 is equal to 2.414x. so therefore x is equal to, therefore divide both sides by 2.414. Interesting. Okay, how about CT? 1 times 10 to exponent 7 divided by square root 2 plus 1 equal to, it's the same thing. Okay, but anyway, we say 10 times 10 to exponent 7 divided by 2.414 sugala 1 equal to, now I answer it, it's 4 point, no, not 4 point, but it's 4142502 comma 07, yeah, 07. So meter. So this is the distance between planet X and the satellite. Oh, now abufuna ukuyibhala using ilogai scientific notation uzothi 1 2 3 4 5 6. So therefore x wakho kuzoba equal to 4.14 times 10 to exponent 6 meters, right? Nangabe umuvela your decimal point to the left, your exponent ka 10 izoba a positive. If you move to the left, your exponent is over, if we move to the right, your exponent is over negative. So this is our answer, guys, for 4.3, which is the last question for our question 4. Now we enjoy this video, please leave a like, ungakhohlwa subscribe, ungakhohlwa share, ungakhohlwa comment, and a question. Let us discuss. In the description box uzothola ama links for other recordings engwayenzile for the question paper. For now, asibonane on the next video. Bye bye.